Good morning, children. Today we are going to discuss about the classification of computers based on analog, digital and hybrid classification technique. Computers are classified into various categories based on their characteristics, capabilities and usage. Based on the function performed, the computers are classified into analog, digital and hybrid. Now let us start with analog computers. Analog computers are a type of computing device that work based on the principles of continuous data representation and the use of physical quantities to perform the calculation. Analog computers deal with continuous data. They can represent and process values that vary smoothly over a range. These values can include physical quantities like voltage, current, temperature, pressure, etc. So, analog computers consist of various analog components like resistors, capacitors, inductors, amplifiers, and operational amplifiers. These components are interconnected to form analog circuits. They also use analog devices like potentiometers, analog meters, and oscilloscopes to visualize and interact with the data. Analog computers perform mathematical operations by manipulating analog signals in real time. They can solve differential equations or simulate physical systems. Analog computers can use circuitry to continuously integrate or differentiate the signals. These operations are achieved by exploiting the properties of analog components such as the relationship between voltage and current in resistors and capacitors. Advantages of analog computers are, we can analyze that now. Speed, precision and simplicity. Speed. Analog computers can perform complex calculation in real time, making them suitable for tasks that require high speed data processing. In terms of precision, analog computers can provide highly accurate results for tasks involving continuous data or physical phenomena. Analog circuits can be relatively simple to design for certain applications. Now let us analyze some of the limitations of the analog computers. They have limited versatility and are sensitive to noise, and they lack programmability. Analog computers are specialized devices and their functionality is often limited to specific applications. Analog signals can be affected by noise and interference, potentially leading to inaccuracies. They are not programmable in the same way as digital computers, which can execute a wide range of algorithms and tasks. Now, let us look at the applications of analog computers. They have been used for various scientific and engineering applications. Simulating and modeling physical systems such as aircraft, flight dynamics, electrical circuits, and mechanical systems. They are used for solving differential equations for scientific research, particularly in fields like physics, chemistry, and engineering. They are used in control systems for the processes requiring continuous adjustment, like temperature regulation in industrial settings. They are used in analog signal processing, such as filtering and amplification in audio equipment and telecommunications. So now let us pass on to the digital computers. These are the most common type of computing devices that we use in our present day lives. They are characterized by their ability to process and store the data in digital format, which means data is represented using the binary code. Digital computers are versatile, programmable, and widely used across various industries and applications. These computers use a binary number system which is based on the two digits 0 and 1, and all the data and instructions and information, etc. are all in the digital computer are all represented in this binary format. These computers consist of electronic circuits that perform logical operations on binary data, and these circuits are composed of transistors, logic gates like X AND or NOT, and memory elements like flip-flops. The logic gates are used to perform basic operations such as addition, subtraction, multiplication, and division on the binary data. The arithmetic logic unit is a critical component of the digital computer's central processing unit and performs the arithmetic operations like addition, subtraction, multiplication, division, and logical operations like comparisons, Boolean operations, etc. on the binary data. The arithmetic logic unit is responsible for carrying out the instructions given by software programs. Digital computers use digital memory such as RAM, that is the random access memory, and ROM, that is the read-only memory, to store the data and programs. Digital computers are programmable. They can execute a wide range of tasks and functions by running software programs. Programming languages like C++, Python, and Java are used to create software applications that control and utilize the digital computers. These computers use various storage devices to store data permanently, including hard disk drives, solid-state drives, optical drives, and flash drives. These storage devices use binary code to store and retrieve the data. And now we will pass on to applications of digital computers. They are highly versatile and can be used for a wide array of applications, which includes general purpose computing, that are tasks like word processing, web browsing, and data analysis, scientific and engineering simulations, which includes modeling, physical phenomena, climate modeling, and numerical simulations. Graphics and multimedia, including video editing, 3D rendering, and gaming, and communication, which involves data transmission, networking, and internet browsing, and the control systems, which includes automation in manufacturing, the robotics, and process control. Now the advantages. Looking into the advantages, we see that they are accuracy and precision. In terms of accuracy and precision, the digital computers provide a high level of accuracy and precision in calculations and data processing, and also to error checking mechanisms. Next is discrete processing. It processes the data discretely. That is, they can operate on distinct values or states. This discrete nature allows for error correction and precise control. The digital computers have evolved rapidly with advancements in processing power, memory capacity, and miniaturization. They continue to advance with technologies like quantum computing, which could revolutionize the computing capabilities. So the next one is the hybrid computers. They are computing devices that combine features of both the analog and digital computers and integrate the advantages of both the types of computation. These computers are designed to handle tasks that require both continuous data representation and real-time processing, as well as discrete data manipulation and complex algorithmic execution. Combination of analog and digital components. Hybrid computers incorporate analog and digital components within the same system. This combination allows them to process both analog and digital streams seamlessly. One of the primary functions of hybrid computer is to perform real-time analog to digital and digital to analog conversions. These conversions are essential for interfacing with the physical world, as many sensors and devices generate analog signals. Analog data from sensors or instruments is converted into digital format for processing by the digital components, and the results can be converted back to analog for output or control of physical systems. Application of hybrid computers are: they are commonly used in scientific and engineering applications where real-time data acquisition and controls are critical. Some common applications are scientific experiments, industrial control, flight simulations, and weather forecasting. Hybrid computers are used to collect data from scientific instruments like oscilloscopes, spectrometers, and seismographs. They are employed in process control systems, manufacturing, automation, and robotics. They can simulate aircraft performance and control the systems in real time. They can analyze and model meteorological data, which often involves both analog sensor inputs and complex numerical simulations. The features of this. Now let us discuss about the features. Now, at first we will discuss about the components. Analog components in the hybrid computers include analog amplifiers, signal conditioners, and data acquisition interfaces. Digital components include processors, memory, and digital interfaces for connecting to external devices. And now let us look at the data flow. In a typical hybrid computer system, analog data is continuously collected and processed by the analog components, and the relevant information is sent to the digital side for further analysis or control decisions. The digital side of the system can execute complex algorithms, make decisions based on the processed data, and send the control signals back to the analog side for real-time adjustments. And now let us look at the advantages. In terms of speed and precision, these computers are very well known in real-time data processing. They excel at tasks that require quick response times and highly accurate controls, such as in manufacturing or scientific experiments. Flexibility and customization. These systems can be tailored to specific applications. The analog and digital components can be configured to meet the unique requirements of a given task. And with this, we are winding up. In the next session, we will be discussing about the different types of classification itself, but with the different types like mini computers, laptops, Mac, supercomputers, etc., etc. So, children, study well.